Comme ça, ouais. Hello everybody, so, well, thanks a lot for your participation to this first local CNCF meetup. CNCF standing for Cloud Native Computing Foundation. So, well, we are glad to be here in Amadeus, and glad also to see so many people tonight, so that's good, and that shows the interest for this kind of events in Sophia. So we will just make a very short introduction, 5 minutes or so, to present some stuff that is happening in Sophia, and then we will give the floor to the speakers. So first of all, thank you for to our sponsor Amadeus. Well, once again, very glad to be in this great auditorium, and well, for the first time for this CNCF local meetup, that's great to be there. So thank you very much. A quick word on CNCF, so Cloud Native Computing Foundation. Oh, it's not the well, okay. It's not the last version of the slide. It's okay. So basically, CNCF is an organization, and this organization has a mission. So I will summarize the mission, saying that it will help to promote the cloud native application. And for this, well, talking about cloud native application or cloud native system, we're talking about application running containers that are dynamically orchestrated, and that's yeah. Another thing to say. Okay, and to achieve this mission, the cloud native Foundation has several roles, and those roles are first of all to communicate regarding all those technologies, and to help improve their usage, and also improve their reliability. So basically, if you want to know more about the mission, about the role, you can just jump to the CNCF.io website, and you'll see a lot of details on this and on this foundation. So basically, today there are 14 projects that are within the foundation. The first one in history was Kubernetes, and then it was followed by Prometheus, so the subject of today. There are some other projects linked to well, log, to security with Notary, to service mesh, and some other things. And those projects are, well, projects that we'll see in some other meetups, future meetups in Sophia. So just to make things clear regarding this meetup, this is something that we like to do every 5 or 6 weeks. So if we manage to do that, that would be good. In the content, you will have some talks, you will have some user feedbacks like today, and also some discussion on use cases and stuff like that. We will also have the possibility to have some workshop during those meetups, and for instance, we will have a Kubernetes workshop that will come soon, not that defined yet, but this is something that will occur in the next meetup. And basically, and most importantly, this is, well, we want this meetup to be something that you want it to be. Saying that if you want some particular topics to be covered, just tell us. If you want to submit a presentation, if you want to submit a talk, just feel free to do this, and we'll be more than happy to help you with that. So we have meetup.com. Just out of curiosity, how many of you don't know the website meetup.com? Can you raise it? Okay. So, yeah, in Sophia we have some other events. So now the Cloud Native meetup. We have also the Docker meetup, HashiCorp meetup. HashiCorp being the company behind the Terraform, Vagrant, and all those great stuff. And we have also some events running by Telecom Valley or Riviera Jug and some other stuff. Last time someone came to me saying that, well, there's a lot of events in Sophia, but we don't have any hub to know about all of those events. So we just release a website. It's a very, very deeply simple website with a timeline, and this timeline shows only the technical events that will take place in the incoming weeks or months. So just keep that in mind, sophia.events, and you will have all those events linked. And you can also add your own events, and well, we think this can be useful So if it is, that's great. If not, well. But if you want to play a little bit with CSS and with CSS and web stuff to make it look better, just do it and raise a PR. So I will leave Boris talking about the agenda.
Thank you, Luc. So tonight, Cedric and David will talk about Prometheus. It's a promising, very exciting tool for monitoring, and it proposes a new approach. So we will see if it's our new best friend in monitoring and the potential drawbacks. So thank you for the speakers to give us some input on that. Okay, so thank you for attending. As Luc said, we are expecting some input from you about topics. We are planning a Kubernetes workshop, but also probably a series about Kubernetes. So we would like to have some ideas about what you would like to learn about Kubernetes, to have some knowledge, to get some knowledge about in a workshop. So if you have ideas, send us mail, else we will build some agenda. So stay tuned on the Sophia event, and we will get thing. So make us dreaming now.
So good evening, everyone. So my name is Cedric Lamorinière. I'm software engineer at Amadeus, and this is David Benck, also from Amadeus. So before this, explaining what Prometheus can give you, let's talk a bit about why you need monitoring for your application and infrastructure. So first things you need to have, and why you need monitoring is because you need to know when something is wrong on your application and production, when your client is impacted by an issue in your infrastructure. Best things is to be able also to anticipate when it's coming wrong. Maybe having an increase of latency, it's already something that will go to a service outage. So it's better to interact when you have only an increase of latency. Also, thanks to monitoring, you can debug more easily your application, have some insight of what's happened in your application, know which services send error to your client. It's also good to have monitoring when you want to compare the performances of two versions of your application. So when you do canary testing, it's always good to compare the performances of your application. If the new version uses more CPU, more bandwidth, more memory, and if it's the case and it's not acceptable, maybe stop the rolling update of your application. And last point is that thanks to monitoring, you can also drive some technical or business decision. But having a monitoring solution in a cloud environment is something challenging. First, your solution needs to be adaptive. You need to understand that your topology is very dynamic in a cloud environment. Also, you want to have something that can discover automatically new metrics. When an application will push some metrics, new metrics in their new version, you don't want to update the configuration to have it available in the dashboard. Also, in a cloud environment and with VM and containers, when you run application, for example, in Kubernetes, the life cycle of your application is very short. Maybe your container will run only for a few hours before a new version will be deployed. And last things, you want also to be able to aggregate some metrics to build some relevant alerts. So you need to merge several input of metrics to be able to do it. So now we can talk about Prometheus. So Prometheus was inspired by Google Borkmont. It's an internal monitoring system in Google. It is here for since few years, and a lot of maybe more than Prometheus, of course. And it was started, the project, in 2012 by two ex-Googlers working in SoundCloud. He wanted to put in place the same kind of Borkmont outside Google. It was open sourced in 2015, and it was, as Luc says, the second project in the CNCF. So Prometheus is about metrics, not logs, not trace, not events. It's doing only metrics, but it's doing it well. So this is the representation of your application, maybe in a cloud. So you have one services having receiving the request from your user, but after this service will send several other requests to other internal services, and maybe at the end it will go to databases. Prometheus is one process, unique process that is written in Go. And when you want to have to monitor your application, what you need to do is to put some code inside your application to be able to have this information. So Prometheus provides several clients. It's a framework that creates a HTTP handler inside your application. And inside this handler, you can register several metrics for your application. So thanks to a configuration, Prometheus will be able to scrap this HTTP handler. So it's just a curl to this HTTP handler and retrieve all the metrics generated by your application. If you want to monitor a database like Oracle or MongoDB or Redis, for example, and you cannot modify the code of this application, you can always use an exporter. Prometheus and the community build a lot of exporters already, so I'm sure you will find the ones that you need. And the goal of an exporter is to convert the current API for monitoring the databases to a format, the Prometheus format. And like this, for Prometheus, the DB will be as other application, providing the same kind of metrics. Then your DevOps, when you need to retrieve these metrics, you have several ways to do it. The first is to create some dashboard thanks to Grafana. So Grafana have a plugins to interact with the Prometheus server. It uses the protocol and the language PromQL from Prometheus to do the dashboard. And the second possibility is to create alerts thanks to another process that we call Alert Manager. It's provided by Prometheus. The DevOps create and define alerts thanks to the Prometheus format, interrogate Prometheus, and after, when an alert is activated, the DevOps can receive emails, a chat in several plugins. So you have for HipChat, you have for Slack, maybe for all of kind of chat that is in the market. Last thing that you want to monitor is the infrastructure. So with a specific exporter that we call node exporter, is able to interact with your operating system. So it's available for Windows, for Mac, and for Linux. And you will retrieve all the metrics from the system. So the CPU, the memory, the bandwidth, the network, and so. So thanks to this system with exporter and internal client, everything is seen as one endpoint and is very generic. So like this, Prometheus can be very efficient to scrap this metric. Talking about metrics, you have 4 different kinds of metric in Prometheus. The first one is counter. So a counter always increase. Then you have the jauge. So this is a double value from 0 to what you want. Then you have the histogram and the summary. So it's enough about talking. Let's David do a demo.
Yeah, let's start a demo. Can you hear me well? It's okay. Thank you, Frederick. So what we're going to do is to first play with Prometheus and an application in a local machine. Okay. Later on, you've been distributed some papers with some IP addresses and so on. This is for the cluster part of the demo. Just for the Amadeus audience, just if you want to play with the application, please use the guest Wi-Fi, not the Amadeus one, because the firewall will block you because we are using some range of ports that are not allowed. Okay. So use the guest Wi-Fi, please.
So what I'm gonna do is I've prepared a script here to start a local instance of this is stop, not launch. So this is gonna launch a local instance of Prometheus, the server, the time series DB, and the Grafana, so the UI that Cedric explained you about. And it's gonna launch also the node exporter. Everything is running on my machine under Docker. So now if I do a Docker PS stuff, you can see that I have 3 containers running, one being the UI, the other one the Prometheus server, and the node exporter. So I'm gonna go directly to the UI of the Grafana, of the Prometheus. So Prometheus itself as a UI, it's not really convenient, but really helps when you set up your Prometheus. First, you can see here that when I have started my Prometheus instance, I pass some configuration here to say to Prometheus what to scrap, what to monitor. We can retrieve this directly in the here in the configuration section in the UI. And I'm going to go quickly through. Yeah, I increase this. Everybody can read? Okay. So what we are telling to Prometheus server here is to scrap metrics every 15 seconds in a global scope, to time out every 10 seconds if nothing comes back from the endpoint, and evaluate the time series every 10 seconds. This I come back later when I speak about federation. And I have defined in my local instance 3 jobs, okay? 3 scrapping jobs. The first one, I'm going to take the last one because it's related to the famous node exporter that Cedric told you about. I'm going to ask Prometheus to target every 5 seconds endpoint that is behind this IP port, this URI every 5 seconds, okay? This port is the one exposed by the container here, okay? Then I have 2 other jobs. One for the application that is called Resto, standing for restaurant. We'll see that in a minute. It's not started yet. And we have a last job that is Prometheus. Prometheus scrapping himself. So you're going to have some insight also on what's happening inside Prometheus. Okay? So before going to more graphs and everything, let's have a look of what's beyond these endpoints really. If Cedric told you that it's just like a simple curl, let's do this simple curl to really see what's happening and between the application and the Prometheus on the network. Oh, this is my endpoint. Metrics. I'm going to do that. Okay, so this is what's going between the application and the server Prometheus. So everything that starts by dash, of course, is a comment. You have help and a type. Remember, one of the type was George. It's there. And we have a lot of metrics. This one is the endpoint of the node exporter. By default, this node exporter is exporting something like 500 series. Okay, so I'm not going to go through all, but some meaningful one for you maybe. The CPU frequency, it's per CPU, and we're going to see later on a few things related to disk, and so on and so on. So this is really what's happening behind the scene. So you have a metric name, a series of labels, and a value, numeric value. Remember, everything is about metric here, okay? So if I go back to my Prometheus instance, I can see not only the configuration, but also, wait, it's not going, oh, sorry. But also what Prometheus is targeting. Here on that panel of Prometheus, I can see that it's scrapping the metric of node exporter, it's scrapping Prometheus itself, and the application Resto that is not yet there. So here we can see when an endpoint is failing, already you have something appearing on the Prometheus dashboard here. Let's start this application. So this is going to run on my machine, same network, host network, and now the Prometheus is able to scrap this program. We're going to see in a minute how I build this program. See that each endpoint has some labels. especially the last one. You see this application restore here? This is something that I have append to my configuration. I don't know if you have noticed it. It's there inside the configuration. I said that when I grab this endpoint, resto, here, I want to attach label restaurant. So this is very important. If you have multiple endpoints, you can attach metadata to each endpoint, okay? I would like to show you a few things about something that Cedric mentioned that is called the PromQL. The node exporter is exporting many metrics. Let's have a look about to, for example, what are the number of bytes transmitted. Let's execute this. And what I can see here is that I have 4 series, each series being for a tuple of a label, all for the job node on the same instance, but for different devices, okay? And I can start playing with the PromQL language here. For example, I can say that I want this over the 5 last minutes. And here I will have a different output because the value are now displayed according to the number of points that I got every 5 minutes. And I can start also doing some filtering. For example, I can say, okay, now I want only the device that is called ENO1. Boom. I don't know if you have noticed, but this has changed here, and I have only that one. Let me remove the time range so that it's obvious for everyone that I have only one series now. And I can do other stuff like, for example, I take again, let's say 1 minute, and what I would like to do is to have the rate, not only the sum of bytes, but the rate for that. So the last minute, obviously there was nothing. Even on the last hour, what did I do? Wi-Fi. Oh, yes, I need to go for the Wi-Fi device. Let's remove this. Boom. So here now I have the rate for every stuff. I can change and go to how it's called, this one, WLPS LP3S0. No. Device equal. Okay. And if I add still several stuff, I could sum something like this, for example. But here the sum on the same thing, it's not going to change everything, a lot of stuff. And for example, you see that, well, we see more stuff in Grafana. So here we can, I show you few things only about the PromQL language. I encourage you to go and see the website where you have tons of things about the PromQL language. All the operand functions that are there are very, very fun to use. Now that I have launched the application, I can see few things about my application. My application is exposing some metrics that are called demo. Here they are not appearing yet because I haven't generated any traffic. So I'm going to go to this application that should be here. That is the same one that you have on the URI that have been distributed to you. And I'm going to order some pizza and fruits and ask for this, ask for several. And then if I come back here and I refresh my page, suddenly I'm going to see that for demo stuff, I'm going to have some metric popping here. Okay? And it's an histogram, so I have buckets, I have count of command, I have some of the values that I have done. Quickly, I would like to show you how to instrument your code. If you're a C++ guy, you would like to see this, for example. It's always the same thing. Whatever the language, you're going to have a couple of things to do. First, expose the HTTP endpoint for Prometheus to scrap. So this is this line here in C++. You will have to register your metric. So here it's a counter in this example that we have here. Here the labels are quite static, let's say, in this example. And finally, you register your metric in the exporter. And in the end, in your program, in the logical part of your, or business part of your program, you do something with your metric. Here, it's just an increment. Let's see another one with what I've done here. For example, I think it's this one. If you look at Go, what you would have to do is import some package from the client library, declare your histogram. In my case, it was an histogram, sorry. In my case, it was an histogram here. Then you will have to handle the HTTP endpoint and update your metric. In my case, the value of the label are a bit dynamic, meaning that I take the value of the plate and value of the dessert for each observe that I do. Okay? Any question for that part of the demo? No? Okay, so we can continue maybe with the slides. Oh yeah, I forgot one thing, sorry. Fred, can you switch back? Sorry, one thing I forgot. Is to show you that the local dashboard, yeah, Grafana, that is deployed locally. And here we have, sorry, I forgot that. Of course, the Prometheus UI, I told you it's weak. Okay, we can use Grafana, and here, for example, I'm reusing the dashboard of that is given by the node exporter, that is attached to the node exporter, and you can see that what's happening on my machine, okay, during the last 5 minutes in terms of CPU load, memory usage, disk I/O, network. Here are only few metrics. I told you that the node exporter is providing something like 500 series. Okay, just speaking about to give you some idea of volume, the node exporter. The format you have seen, it's a text, it's going through gzip, HTTP, and gzip. I did some math, and if you have a cluster of 5,000 nodes, the cost is going to be 60 megabytes per second if you scrape per second. Okay?
Okay, so this is a representation of what we just show with David. So everything in this local laptop, the Resto services in local, the Prometheus, the Grafana, and the node exporter. David showed us also some PromQL requests, how to build it. You can really create some complex PromQL requests. For example, the 95% till latency of a specific data center or specific application. You can also estimate what will be the disk usage of your application in 4 hours, so you can do a predictive result. So it's good to create alerts, and also you can use a lot of methods, Prometheus method, like for here, to create the top 5 Docker images that use the more CPU on your data center. So you can use top key 5 with sum, with rate, and like this you can create some very interesting results with PromQL. So Prometheus is already well used in the cloud environment and integrated in a lot of applications. So you have already endpoint in Docker, in etcd, in Consul, Kubernetes, Prometheus himself, like we saw, Grafana, and Istio. For other applications, like his more legacy application, let's say, we have exporter for MongoDB, Redis, Kafka, Postgres, MariaDB, JMX for Java, and so. And for your application, you have a client provided by officially by Prometheus in 4 different languages: in Go, in Java, in Ruby, and Python. And for other languages, the community already built some clients. So you have for Bash, C++, Rust, Node, Lua, and so. You can go to the Prometheus documentation to have the full list. Another interesting feature of Prometheus is the service discovery. So as I say in my first slide, what is interesting when you run in a cloud environment is to have something that automatically configure your Prometheus endpoint. And for that, Prometheus already use several orchestrators, so obviously Kubernetes, but also Consul, Docker Swarm, Mesos. if you have your own orchestrator, you can build your configuration automatically with a feature called static and file config. And like this, you can push in Prometheus your own configuration, and it will automatically update the Prometheus configuration. If you run in a cloud environment like GCE, Azure, EC2, or an OpenStack, Prometheus also is able to get some information from it to retrieve the list of IP of your VM. And so let's have a second demo about service discovery.
So if you want to help me for that part of the demo, please use the IP and port that you have received on the paper and do some order, because if you don't, we won't have any metrics to show and not any diagram then.
So you can explain.
So quickly, what the URI, by the way, is this one over there. So previously we had everything looking into my laptop, and I show you a very static file through the Prometheus UI, where everything was written by me, basically, and injected in my Docker container. But if we start going to a cloud and we have a huge system, and we are not going, obviously, to write that file, so what we are going to do is we're going to reuse the orchestrator of our system, in our case Kubernetes, to find these targets. So I'm not going to explain Kubernetes today, but in Kubernetes you have services that and a service discovery mechanism that help the system to find where are your servers, okay? And the Prometheus instance is going to connect to that Kubernetes instance, and what you're going to say as a configuration is just say, please scrap the target behind this service name. And after that, Prometheus will find the IP port in the local network of your cluster and do exactly the same thing that we have seen previously.
So in this demo, we are using the Prometheus operator. This is proposed in open source by CoreOS, and it allows us to deploy automatically Prometheus and Grafana inside Kubernetes. Yeah. It helps us a lot. It simplifies a lot the deployment.
So Frédéric, if you can switch, please. So what I'm going to show to you now is, you remember this local file that I wrote, I showed you earlier, this one, sorry, status config, that was really simple, written by me by hand. Now if I turn to my GKE cluster, I have much more bigger information. This is because the CoreOS operator that deploys Prometheus comes with a lot of stuff. I'm just going to dig into the one that is associated to my application. Just to tell you...
Maybe you should increase a bit.
Yeah, I'm going to increase this size. And before going there, I'm going to show you the exact file that I sent to Kubernetes for Prometheus to scrap my application. I've sent this resource. Okay, let me put it on the left side, maybe. Oh, it's okay. You can read? It's okay. So what I'm saying here to Prometheus is to scrap every target that match application resto, okay, on a port named web. So in the service definition, this will map to a real port, 8080 in my case. I want it to be scrapped every 10 seconds. I want the job that is generated on Kubernetes side to be called K8 application, and it will go to every namespace that are default. So let's go to the configuration now and see how this has been translated into a Prometheus configuration. I'm going to search directly like this. Okay. And here is the job that has been generated by the CoreOS operator behind the scene. So we retrieve the scrapping interval. We still have the default endpoint. And we see that it's using Kubernetes service discovery config. It's searching for every endpoint in namespace default. And here we can see that he says that he wants every label that is called app to be named resto, and it will keep that endpoint. This is what this means. Next, it will keep only the endpoint that have a port name web. Remember my config. And after that, I have some other definition that helps me to append more label on the metric that will be scrapped on this endpoint. Let me show you what this results in terms of target. In terms of targets, let's focus for the moment only on restaurant. I have the Prometheus server has found 3 targets in my cluster behind this IP, on this web port, behind metrics, and it has labeled all these metrics with the label that are in blue, appearing in blue here. Okay, so the only label that change are, of course, the instance that are the IP of the pod and the name of the pod. And you have the last scrap time here. As a result, I have this, of course, available also in Grafana. We'll see that in a minute. And what I would like to show to you is that all the stuff that has been coming for free for me, thanks to the Prometheus operator. It's scrapping Prometheus itself, it's scrapping node exporter, it's scrapping Kubernetes, it's scrapping a lot of stuff. What does it mean? If you look at Grafana that is provided with the Prometheus operator, you have all this list of dashboards that comes almost for free. I'm going to show you only one today. For example, the Kubernetes capacity planning. This is a dashboard that comes with the Prometheus operator that shows to me the status of my cluster. Okay? So you have everything like, by the way, you have access to this with the URI that we distributed to you. Okay? And I have built some custom dashboard for my application. I also retrieved the node, that is the node exporter related dashboard. So it's exactly the same dashboard that I had on my local, but here it's from the cluster. By the way, you can see that I have 3 nodes. Here I can select every node. And for the restaurant, there is one that I wrote here. And thanks for playing. We have some data. What we have here, for example, I'm going to show you the PromQL query in a second, is the 90th percentile for your decision time to take a menu. Okay? So, for example, we can see that you were very quick in choosing a pizza and no dessert. And you were very low in choosing what? What is this one? Mousse. Taking the mousse au chocolat takes time, apparently. Okay. So let's have a look quickly to the query, a PromQL query, because I'm not an expert. I took it from website, but basically here I'm saying I want from my histogram I want the 90 percentile for each bucket over the last 2 hours. Obviously, if I put 1 hour here, we'll have the same result because we are here for less than 2 hours. And I'm saying that I don't want to look at all this dimension on the metric. Okay, this is without all this job, service, and everything. So I can focus only on 2 dimensions that are dessert and plat. Okay, so here you will see appearing in the legend all the different tuples. The dashboard that I have built just below is it's cumulative, and it's the quantity that you have taken of each of the menu. For example, big success for pizza and fruit, apparently. And the last one, we will use it a bit later. I think if you have any question on that section. No, we go on?
So let's now discuss about efficiency of the solution. So as you saw that you can put as many labels that you want on your metrics. Be careful with the number, but normally you can put as many as you want. The value that you have in the different metrics is a double value, and you can put Unicode in your labels if you want. The storage is very efficient in Prometheus. It uses 3.4 bytes per data point. Before the version 2, since the version 2, they decreased dramatically the storage layer. They rebuild everything, in fact, for the storage, and now it's only 1.3 bytes. So at the end, one Prometheus server instance can handle millions of metrics in parallel and can scrap hundreds of thousands data points per second without any problem. If never you have more than this in your application, Prometheus offers the possibility to scrap one Prometheus by another Prometheus, and that we call federation. And like this, you can create a tree of Prometheus in order to scale your solution by having several Prometheus servers on your different data center. For example, only one Prometheus aggregated everything to have a global view of your system. And this is what David will show us now.
Yeah.
So this is what we have put it in place for showing the federation.
Yeah. So what I'm gonna do, and by the way, I've already started it, it's to run a federation Prometheus container on my machine. And this federation is gonna scrap the local Prometheus that I ran in the previous part of the presentation, but also the one that are running on GKE. On GKE, I have two clusters, GKE1, GKE2, reason why you have two lines on your paper. And now I'm gonna aggregate all the values into one single Prometheus called Prometheus Federation, okay? Frederic, can you please switch the screen? Thank you. So the configuration for that federation, I did it on my laptop by hand, okay? And it's looked like this. I'm gonna scrap every 30 seconds. You remember the previous scrapping configuration was every 10 seconds. Now scrapping 30 seconds in the federation means that I'm doing kind of downsampling here. I'm gonna have far less points in my federation than I have in my local instances on each cluster. If you remember there was one thing in my previous configuration, external label. On my local machine, it was called local David. And if you, I don't know if you have noticed it, maybe I haven't shown it, but in the configuration of each cluster, for example, here I'm on GKE1, I put external label GKE1 here. And if I go to my GKE2, I have here something different. This helps to put some more label at the time of the scrap at the federation. Depending on the source where the values come from, Prometheus is going to add some more label. So I am able to know after all scrapping inside the federation which metrics come from where. And this is what I'm going to show you now. So before going there, I'm going to tell you what this configuration means. So I'm doing a job called federation. I'm scrapping only the metrics that are labeled demo or node network, for example. So I'm kind of filtering. I don't want everything coming from the cluster. I scrap every 30 seconds. The endpoint is a bit different. It's no more metrics, but it's federate. I'm targeting the Prometheus server themselves. And here are the IP addresses of each Prometheus server that are part of the federation. As you have seen on the first diagram, there is a one-level federation here presented. But you can build any kind of tree that you want. Nothing prevents you to scrap the federation itself, okay? And up to you in your operation to define, if you build a big tree of Prometheus federation, to define what is going in a branch. You can use many branches to dispatch the workload, or you can use branches to differentiate types of workloads and metrics. And after that, what you end up is you can build dashboard. So here I've built a dashboard that aggregates value from all the clusters, okay? And I can see, for example, if I go to GKE1, I don't know why my first graph does not show, but anyway, I have the top values and everything. Someone managed to inject tiramisu. Congratulations. That was not there before. Playing with URI is nice. So you can see that on my GKE1 I have these values, but I can filter out and see if people have played with GKE2. And here I have a bit less values, and I can go for all if I want an aggregate thing. I'm sorry, I don't know why this one are not appearing. We should have seen the rate of plates and booking. Anyway, let's continue with federation. I told you about downsampling, and I think I'm done with federation. Any question on the federation itself? Yeah. You mean so the question is it possible to set up HA on the federation itself? It's not something that I have said, but it's true that on the GKE cluster that we are running 2 instances of Prometheus. Okay.
I will talk about later.
Yeah, we're gonna see that in a minute. If you put 2 clusters, two Prometheus for federation, you will scrap double. And the same way, you will have 2 instances doing the same thing in parallel, aggregating the same kind of data. So my answer is yes. The same way you run the HA Prometheus in an HA way inside a cluster, you can run the federation the same way. So here to answer the question about HA, the Prometheus instances on GKE, we have 2. On my laptop, there is 1 Prometheus and Federation 1. But to answer your question, we could run 2 instances of the Federation. There's no problem with that. Can you speak louder, please?
Matrix will be vertical.
You can have a small difference, that's true.
But at the end, they will converge to the same value since it's only a counter that always increments, for example. So you will at the end, the value will be the same or very similar.
Same trend, at least. Yeah, we're going to speak about the storage.
So we saw how to generate metrics, but you will not ask someone to watch, and we saw also how to create dashboard, but you will not ask someone to watch a dashboard 24 hours per day to know if something wrong happened. So that's why Prometheus also offers the possibility to create alerts. So this is a template of a simple alert. So you need to provide a name for your alert. Then the expression, and the expression in fact is a PromQL request. And then you have the for, and the for means for how long you want this expression be valid or active to trigger the alert. Then you can put a set of labels on this alert. So for example, the severity, when it's critical or a warning, but also you can put the name of the team responsible for this alert. And thanks to that, the alert will be triggered to the correct team after. Then you can also have annotation, summary and description. So it's quite similar, but summary should be shorter than description. And here you can put the explanation of the alert and maybe also how to fix it. So this is a simple example of alert that is looking at the HTTP response code and checking that you don't have more than 2% of error code superior to 500. During the last 5 minutes. If it's the case, you will trigger a critical alert, and in the summary you will be able to put the value that is returning by this expression. Another more complicated alert is to check that your file system, the root partition, is not too much used. So it checks that you have at least 20% of space on your root system. So for that, you use some metrics from the node exporter to do it. And at the end, what you can see in the summary and description, you can put the value of the current usage, but also you can put the name of the instance that generates the alert, so the name of the VM or the machine. When you do alerting, you want to be sure that the alert will be triggered when you have a problem. That's why Prometheus provide a way to do H-check configuration of Prometheus. So for that, you will need to scrap in with 2 instances of Prometheus. So it's not very costly for your application since it's only 1 HTTP call. And like this, if one Prometheus instance have an issue, didn't have no more memory, or the node where it's running failed, you will still have your data in the second Prometheus instance. Then you run 3 different instances of the alert manager. This is the process that is managing the alert, deduplicating the alert since you are scrapping on 2 different Prometheus, and rerouting the alert to the different channels like email, SMS, Slack, HipChat. So the alert manager process are communicating together to deduplicate the alert and also to validate it, to validate the alert. So let's see which kind of alert we can have. This is I'm connecting to the GKE1 cluster. If I go to the alert part, we can see that we have a lot of different alerts, and most of the alerts here are provided thanks to the Prometheus operator. So you can see that we have alerts to verify that the different process of Prometheus is running well, and if not, it will trigger an alert. I created 2 alerts for this demo. So the first one is a resto service outage, and here I'm looking at that the services provided by David have at least 1 instance running in the cluster. Else, I put 10 seconds to trigger the alert to have something more responsive for the demo. So let's see how we can do. We can trigger it. Can you scale down the?
Yeah, a second.
So currently I have a simple dashboard. So you can do dashboard also in Grafana for your alert. I have no alert here, and my services is okay, and I still have some mousse au chocolat. This is the second alert that we put it in place. So currently we have 3 pods running for the application.
So you don't see it, but I'm scaling down the deployment of the application down to 0. So it's something ongoing now. So it's effective now. So you're gonna see the alert triggering in a couple of seconds.
So if I come here. So it can take a few seconds since it will wait 10 seconds to be to have the information, and also it only scraped every 10 seconds. So here we can see the error is in pink. It means that it discovers the issue, but it didn't fire for the moment the alert. And if I go here, refresh it, into this a bit, and now I can see that I have an alert in my dashboard, and the status of abilities is KO.
Do I scale up now?
Okay. Yeah, you can put back. So the second alert that I have, it was about the number of mousse au chocolat that you ask, and it was another simple alert that we count the number of requests for mousse au chocolat, and if it's superior to 100, it means that we don't have any more mousse au chocolat. We need to reduce some mousse au chocolat.
So. Yeah, I need to book.
Yes, so
100 mousse au chocolat now. This is what I'm doing. The people who injected tiramisu can help me by doing some scripts and booking some mousse au chocolat.
So for the moment, we have just 25 mousse au chocolat, and you need to wait a bit. But anyway, so this is the same principle. You can create alert on all the different metrics. You can aggregate other stuff. I need to refresh it. Yeah, and we restarted the pod, so you lost the previous value.
I lost the previous stuff.
So anyway,
it's gonna.
Do you have question about alerts? No. You really want to go to 100?
Well, I was about to, but it's the Wi-Fi is a bit low.
Maybe
I'm close.
you are close.
So the alert is going to take a few seconds to be triggered. So here you see on this graph that we have lost history. Okay, this is because my PromQL query is not taking a sum of everything that was done, for example, in the past hour, but only recent stuff. So as I have restarted my pods, yeah, I have only few stuff on the in the series. It's not there. Should be, huh?
No, I don't know. I miss up my alert, I think.
Ah.
So anyway, we saw the first alert.
One comment on this one that you have seen. Can you go
Yeah.
back? So there is one alert that is always triggered here, that is there by default, this dead man switch stuff. It's for you to verify that your complete flow till your pager or till your Slack is working fine. Okay, so this is an alert that always show up, and that allow you to validate the complete flow toward your DevOps guy. Ça a pas marché?
No.
Weird.
Well, let's continue the
So-
presentation.
Yeah, so what we have seen with this presentation, before going to the feedback, a quick recap. So at the center, we have this Prometheus process that is a time series DB that is storing everything. So I had a question about storage. Yes, it's storing locally here, okay? And Cedric said it in the presentation. When your series is started, any new point in the series costs in average 1.3 byte, okay? So depending on the size of the disk and memory that you put behind this guy, you can probably take a week, if not weeks, depending on your workload, of course, of data in the memory of that single process. You can persist it to the disk, but if you want something to be stored for a long time, okay, to do some capacity planning, years after years and so on, you will definitively need what is on the bottom right of the picture, export to long-term storage. So there are many things going on this side today in the community, especially with InfluxDB. You have exporter toward InfluxDB, and you can even run PromQL directly on the InfluxDB. There are even some two-way binding where you can do your PromQL inside your Prometheus server, and if the range of time that you are trying to access has been exported already to the long-term storage, it's going to call the InfluxDB behind the scene. Okay, so this is work ongoing now. But everything that we have used here was in memory, and we have not even set up the HDD storage. Okay, we have seen the PromQL that helps you to read this time series DB. And we have seen that this Prometheus server is scrapping application or exporter, okay? And you can configure your Prometheus different way, but the most common way is to leverage the service discovery mechanism that is used in your company, Prometheus if it's there. If you have your homegrown orchestration system, you can still use SD config and static config to build files on the fly that will be consumed by Prometheus. Cedric has just demonstrated the top right part, that is the alert manager. And finally, we have seen the web UI, so the very simple one by Prometheus product itself, so very simple. And the Grafana one where you can do much more things, and it's more easy for your DevOps to read. Do we have any question on this architecture before we go forward? No? Okay.
Okay, so to conclude this presentation, some key takeaway. So first thing, that if you want to use Prometheus in your company, first you should instrument your framework and middleware that is shared between apps. Like this, you will have already some metrics for all your application, like the response time, the number of error, the bandwidth used, and so. If you are migrating from another system like Nagios, maybe you can find an exporter that will be able to grab the information from Nagios and put it in Prometheus, and like this you will be already able to show the value of Prometheus. Then some advice. So when you put some metrics, some labels on your metrics, be careful when you choose it. As we say, each time you add some labels and you have different labels value, it will increase the size used by Prometheus to store these things. So don't put the user ID, for example, or an incremental value, else at the end your Prometheus will not have any more space quickly to store the value. Then limit the number of metrics that you have. You should not think about metrics, but should think about alerts. When you want and create the metrics links to the alerts that you want to create. And last point is avoid flaky alerts. So put some alerts that really is really relevant and not trigger every 10 minutes. Else, the on-call guy will never look at the alerts that shows up in this mobile. And now let's have some feedback from other people.
So let's welcome Matthew from Ricardo. We'll share some experience on Prometheus in production at Ricardo.
Hello everyone. Just give me 2 seconds to put my screen up.
Can you switch to the HDMI? Yeah.
So hello. About 1 year ago, we started to split our monolith into microservices. One challenge we faced, like Cedric and David said, was how to monitor our application in this highly distributed world. What I want to share with you is what we have learned, the mistake we have made, and my hope is that you will be able to avoid some of them. We are a Swiss-based company, and we work in 3 countries. Our traffic is around 4 million page views a day. We are about 180 people, and this company exists in 18 years. So you may ask yourself, why Prometheus? When we split from monolith to event drive and microservices, we switch also from .NET Microsoft to Golang, Node.js. We switch from VMs to containers. We switch from vSphere to Kubernetes. And we switch from Zabbix to Prometheus. What led us to choose Prometheus was mostly the CNCF. Because when you have a look at Kubernetes, naturally you have a look at the CNCF. And one of the first shows you see is Prometheus. So you look at it, you play with it, and we loved it, even if we do not forbid us to change at some point if it does fit our need. So just to talk a little bit about what is Prometheus at Ricardo. Currently, we mostly scrape 355 targets each time we do scrapes. So it means each time we will scrape our infrastructure, we will measure 379,000 metrics each 15 seconds. And this scrape is performed on less than 150 milliseconds. What it means is that during 1 week, we have 11 billion of values that are stored by Prometheus. Just to give you an order of what the instance look like or our setup look like, currently it's really small because we just wanted to start, and it's a single container that runs inside Kubernetes. It's only 7 gigabytes of RAM and 60 gigabytes of disk usage for our retention. So, as David and Cedric said, Prometheus is a time series database. What he loves it's when time increases. Whenever the time increases, it's not an issue. But as they explain, if you have incremental IDs in keys or values, it will be an issue. And we faced it because some engineers thought it was a good idea to measure the response time according to the path of the HTTP request. It is a good idea, but not if you have Prometheus behind. Because if you have that, it means you will create a new time series each time a new article is put on production. And when, like us, we have more like 1,007,000 articles in production each day, it hurts, and it hurts badly. So do not do that. Use a wildcard on your path and use some other way if you need to measure an article that have a too long response time, like the logging, as an example. But even if it's a time series database and it's fun to play with it, it's still a database. It means when you have user inputs, like URL parameters, you have to deal with it. You have to sanitize it. You have to do type conversions, type checking, checking against a predefined list of whatever you want. Why? Because users will try to hijack you, like the tiramisu as an example. And on our side, we faced near an issue. It was not an issue in the end, but we discovered that someone tried to hijack us doing an SQL injection by having a look at the labels created inside Prometheus. Because we didn't thought that someone will inject something else than a number in a parameter called width. Yeah, but users do what they want as soon as it is an exposed parameters. So think about what you inject into Prometheus, because in the end, it will be able to harm your monitoring process. And this is definitely not good for you. And as they said, you should definitely care about the names. Because if you want to have a global overview, if you want to know regarding the sales services, did the response time is under the SLA or not, doing this aggregation by letting each team doing their own labeling, their own keys, then it will be nearly impossible for you to know what happens. And you will not be able to aggregate and to correlate these things. So it's definitely a good thing to invest in the beginning on why the metrics are named this way. Prometheus really explain it on their documentation, and it's clearly explained. But usually on the SDK, the parameter configuration are not clear enough, maybe, because they talk about name, namespace, and when you are inside your application, when you talk about the namespace, you talked about what? Sales, accounts, anything like that. But for Prometheus, he don't care about your organizational chart. For him, a namespace is more HTTP related or gRPC. So you really have to understand the way Prometheus is thinking. And one of the way Prometheus is thinking is the types of data you can store in it. There are not that much, only 4. But you have to understand what they are for. As an example, with a summary, you can measure the percentiles on your application, but it will be exposed only on your application. It means the client SDK will perform the math. It means in the end, the RESTO app will show that my 95 percentile is under 200 milliseconds. Great, but what about the overall application view if I have more than one pod in place? If you want the overall application view, summaries will not be able to provide it to you. And you will not be able to translate it after. So you have to think, when you build your application, what is good for you. And you have to understand what is behind these words. So you definitely have to take care and think about it. Otherwise, it will just be useless. And what was also good for us is that we have struggled a lot with Elasticsearch by storing our logs. But when we came to Prometheus, we just had to find a good retention that fits our needs. We mostly need Prometheus to do direct alerting. We are in a world when we deploy in our company, more than about 50 times a day. So we need to react fast, and we don't care about 100 days ago, or at least not on this monitoring system. So for us, we just said, okay, 10 days, that's great, that works. But if that doesn't work for you, just modify it. It's just a configuration value, and it works. When we started to use Prometheus, we used the v1.8. And it was kind of hard, because at some point, we had an application that exposed 1,000 metrics. But this application was deployed at 12 instances in our cluster. Not that much. But in the end, Prometheus was totally unusable. When we query the page, the application was just stuck. So we tried to reduce the number of labels, but it still didn't work. We knew the V2 was coming, so we just wait and upgrade, and then everything was working perfectly. So we didn't try to invest much more time in order to understand what was the reason. So my main message here is use this new version. Like they said before, the data storage is smaller. The consumption of the CPU, of the memory, of the network is smaller. Just use it. And regarding the data migration, so we had to migrate from 1.8 to version 2. Prometheus provides some kind of data migration, but they said the best way to do that is to run 2 instances at the same time, wait your data retention period, and kill the old instance. And it's the same for high availability. It's just something that scrapes things, and you look at trends. You do not need to have the exact same data. It's not meant for that. But like I said, at some point, we had these engineers that wanted to do something great, having the response time by each article ID. And our cluster crashed a lot. I mean, like during 1 month, we had to erase all the data of our cluster at least 4 times, without knowing why. We were just going to the page, 500 errors, stuck. So we erase the data, start again. 1 week later, stuck. Okay, well, how to go there? And at some point, someone was, let's say, interested enough to find why. So what does he do? Having a look at metrics, Prometheus metrics. And Prometheus exposes the metrics to allow you to understand what is going on behind. Like, how many series do I am currently scraping? And if you see this trend, like a memory leaks time series things, you know something is not going wrong, the right way. So it was, in the end, easy for us. We changed the apps, and so far, no outages since more than 3 months regarding that. But when we talk about outages, we talk about alerting. And for us, what is really important now on the alerting is to avoid at all costs the noise. Because during several years, we had a poor alerting system, and lots of engineers were disturbed. We have kind of 6 engineers at the same time doing on duty 24 hours a day. And it cost a lot to the company. So it was made lots investment into our alerting system. And when Prometheus came, we just decided to say, okay, when you want to do this new shiny alert that you say it will not page us in the night, you first go in the Slack channel, and we will have a look. So we have just 2 levels of severity. 1 warning that redirects the alert into a Slack channel. We monitor it during 1 week. And then we have the critical thing that will page on a 24-hour basis as an on-call engineer. That is the level 1. But for that, we just take the time. Because if you are paged and it's for nothing, then you just skip the alert and do not react anymore. And we do not want that. And also, we have lots of alerting today that is based on user end-to-end testing behavior and things like that, like ping DOM alerting, etc. But the main issue with that is that we are reactive. We wait kind of 10 minutes before going to do something. Why? Because lots of time during the night you were paged, and when you came back to your computer, the alert was already solved. It's the problem when you do end-to-end user testing, is that from some time is due to the testing method itself. So it's why now we try to do something like David and Cedric shown, measuring the HTTP, the closest possible information to the application. Because the closest you are to the application, the more reliable the measure is. So if you are inside your cluster, and if you are able to know if your application is not responding well, what do we want to do more? What we want to do more is talking about outlying detection. When something goes wrong, if a single pod goes wrong, let's kill it. Who cares? If the others are okay, you should not care. So now I will just show you one of the dashboards we have, and it's my main message here is you can't build a dashboard perfect from day one. It's just impossible. So we started to have this dashboard by maybe having 1 or 2 metrics, and we peer, because when we peer, we are able to have direct feedbacks about what are you trying to say with this curve? I don't understand what you are trying to do here. It does not talk to me. So you go again and again, you have a look at it every week, every day when you are paged, and you try to understand if it's useful or not. And if it's not, drop it, change it, do something, but do not stay like that. So here, for sure, it's not perfect, but at least when you came in, you see KPIs, you see a high-level overview, and what has been done is that the engineers have to think about what are the limitations of the application. Because first, when you start to put some numbers on this gauge, you have to think about, hey, why is my duration, what is my longest duration that I can accept? How many requests am I able to serve in this amount of time? And you really have to care about that. I mean, does everybody do load testing before sending to production? Not on our side, but at least when we do these dashboards, we ask ourselves a question, and then we iterate. So here you can see that we can kind of check how this is the overall status of our architecture, but we can also say, hey, if I want to have a little bit smaller architecture, what will be my KPIs? So we just choose to have some numbers here that are hard-coded. You can change it if you want, just to know, okay, now we have 16 instances, but if I go to 12 instances, what will my numbers look like? And it just helps us to understand, are we okay, and can we decrease our load or not? And of course, you can change your interval, you can have a look, but it's just something that was useful for us at some point in time. It does not mean that it will be useful for you. It's just something that you can do. You think about it, you iterate, you use it. And here you can see you have also annotations. But good news, we do not have any deployments nor pod restart on this app since more than 2 weeks, so I'm sorry, I will not be able to see you the lines. But if you had any trouble, you will have a big line in the middle of the screen to say to you, hey, at this point in time, there has been a restart. So have a look at it. So to conclude, I will just, sorry, I don't know what I have done. I've lost my presentation. So that's it. In the end, the main idea is use your monitoring system, iterate, play with it, and learn how it works. Thanks.
So now we're going to have another type of feedback by François, who have been using Prometheus in his team and inside Amadeus.
Hello, I'm François Rémy. I'm working for in performance team in Amadeus, and we are using Prometheus since a little bit more than 6 months. The agenda is why we decide to go to a new monitoring stack, then why we choose Prometheus. And I will give you some feedback about how we use it in 2 types of usage. The first one is monitoring your IT internally, because we are handling a lab, and feedback on what we are doing on monitoring for performance testing, which is the main job of our team. And then I will conclude what we plan to do. Then why we go to a new monitoring stack. Load testing operation is the main job that we are doing in our team, is injecting some traffic. Is injecting some traffic in Amadeus application in order to test them, then to get some metric back in the monitoring solution. Up to now, we were using HPLM Performance Center, which is a leader on the market. Then we are doing this operation on the lab with a few hundreds of servers. And to be able to test Amadeus product, we need to have use some deployment tool and to get some alerting to see what's ongoing on our lab, if everything is going right during the performance test. Then we recently met some limitation in LM performance testing that we have to solve. And we decided to change our load testing software. And we decided to go for Gatling, which is another solution. But Gatling was not coming with a monitoring solution. Then we have to find out something to replace the previous monitoring solution. On the IT operation is the same. We decided better to use Nagios and old stuff to go with the same solution, because we will have to operate only one solution. Then as Amadeus was thinking about going to Prometheus, we decided to see what's ongoing on Prometheus side. Then we take some information. And why did we choose Prometheus? Is first because it's based on metric gathering, which is very interesting for performance testing. It's your job. Unlike, for example, Nagios monitoring, which is more based on alerting than getting from some metrics based on the alerting, is the reverse. We first get the metric that raise alert upon the metrics. The metrics labeling is very, very interesting feature for us, because when we inject traffic, we can get some labels and labels the metrics with this in order to relate the load injection with the results. The Prom query language, also very interesting for building dashboards. What was very interesting too is the dynamic configuration, because we are changing often the software version that we load in our servers. Then thanks to Prometheus, we have several ways to do that based on static file that we deploy or using some discovery mechanism. Then last but not the least is the integration with cloud ecosystem. As Amadeus is leading with cloud software, it's better to have a monitoring solution that is able to work well with cloud systems. Then the first feedback is the one we had on IT operation. First of all, it's quite reliable. We never reboot the servers during 6 months, perfectly stable. The alert manager that we use for raising the alert that's come on the infrastructure was just fine. With the labeling, we are able to, for example, in this case, to label our farm. This is an alert that's coming from the farm, which is called tool. I'm interested in seeing these alerts. Then thanks to something which is functional on our side, I'm able to receive my alert that's for me, because I'm managing the tool of the team. Then finally, it works perfectly in our environment. Then we have mixed version of operating system. Linux version, some Windows, everything was working fine. And for IT operation, it was just perfect. Then on performance testing, we used to use these exporters in order to do performance testing. The first one was the node exporter to export Linux system metrics, was perfectly fine. For Windows, we use a WMI exporter. It's working fine, but we're still working on it because we have less metrics than we used to have with our previous monitoring system. Process exporter, which is monitoring a specific Linux process, worked just fine. We discover some memory leaks in application thanks to this one. We use a lot the GMX exporter. I will explain a little bit later on another slide what we have done with this. Then it allows us to export all the Java metrics from the JVM, and we start using Apache exporter in order to get some metrics coming from the mod status that's come with Apache. The GMX exporter, we start using it as a dedicated service. Then we had our Amadeus application, which is running on JVM. Then we had another JVM that was running GMX exporter. The Prometheus is scrapping the GMX exporter service. Then the GMX is using GMX protocol to watch what was ongoing on our application. That's the simple settings we find at the beginning. It was just perfect for IT side. We are able to run the GMX exporter even on another server than the one that is running our application. But at the end, purely for performance testing, we had a problem that we start finding problem in the application and response time, and we discover a little bit later that the thread count was just growing too much, and it was perturbating the performance test itself. Then we moved to another solution, is using GMX exporter as an agent. In this case, we just adding some configuration when we start the JVM in order to the GMX exporter to run using the same JVM than the application. Then here, it was perfect for performance testing with the total number of threads that was constant. Then we start using Prometheus, and people were quite happy in the team and start to use it. And with the success comes the problem. We ran out of disk. Probably, perhaps because of labor problem. We're going to study that a little bit later, because I think we are some bad practice on that. The first solution was to add disk, but it will not be sustainable. Then another solution is to use the ability of Prometheus to scrap another Prometheus server that we have seen on the previous demo. Then we're going to scrap, for example, every 15 seconds on the first Prometheus server. Then a second one, to gather long-term metrics, we'll scrap it with a lower rate because we need to keep our data for a long time. And after, we're going to store that even later for long term in Influx database. Recently, Influx provides some more integration with Prometheus, and it will allow to perform this. And finally, we find out that it will fit performance testing, and we start building dashboards. What is nice with Prometheus and the integration with Grafana is to be able to, on a single dashboard, to have both the load injection with some metrics that come from Gatling, then to have, for example, counter coming from GMX, like here we have a garbage collection count, and to have in relation what's coming on the server. And we have a lot of selectors that are using our label in order to glue that together. That's a very interesting feature, and we will be able to build dashboard that we will propose to other team in Amadeus. And finally, we decided to put more things more dynamic in our infrastructure. Then we decided to use Consul. Then the goal is to get some label from our inventory and load engine, the software we are using to put Amadeus product on our machine. Thanks to Consul, we will have something very dynamic. Each time we will deploy an exporter, it will be declared into Consul, and dynamically Prometheus will get the info from Consul in order to configure itself. With the labeling matrix, we will be able to glue the injection with the result from the injection, and everything will be linked to the label, meaning what is the product version, and everything will go in Grafana, and we will be able to expose that on our community portal for performance. That's it for myself. If you want to have questions, I'm happy to.
So we have another feedback, and probably what our next step for Amadeus regarding Prometheus. So thank you, François, and let's welcome Johan.
Thank you. So hello everybody. So I will give another kind of feedback. So I'm Johan Grosam. I'm working in one of the monitoring teams that provide monitoring solution inside Amadeus, and I will give more feedback on how to migrate from an existing monitoring ecosystem to Prometheus. So I will follow this quick agenda. So first of all, the context. Then I will briefly display what is the architecture we target. So it has been partly presented in the previous slide already. And finally, some feedback linked to this integration. So first of all, what we need to understand inside Amadeus is we have plenty of monitoring tools. Until the past 1 year ago, we had tools that were specialized into specific use cases. One tool for functional monitoring, one tool to monitor the architecture, one tool to monitor our VMs. Even if our tooling is pretty good, we see some limitation. One of them is, for instance, we had difficulties to correlate metrics or events that are coming into the different tools. So we are thinking about a solution in which we are able to correlate the metrics together. And another point why we are trying to find another solution is also because we are going towards Kubernetes and deploy application into Kubernetes. So our goal with Prometheus is to monitor the different layers of our ecosystem, from the physical application, the physical machines, to the application itself. Something we need to understand is that people are using the monitoring tools for metrics-based monitoring, of course, but for other use cases. And unfortunately, Prometheus is not usable for other tooling, for other use cases. We are using Prometheus for metrics, but we cannot use it for event-based monitoring. We cannot use it for anything related to active monitoring. So for instance, you have some scripts that test a service into your application. So this is not provided by Prometheus, even if, the need is there, and users request to have all this panel and monitoring use cases available. What we see as well is that there is a need to update our application. Today, I would say in the legacy world, before we had Prometheus, we had a way to provide information to our monitoring tools and were more based into a push mechanism. Today with Prometheus, as we saw, we need to have HTTP port open that exposes metrics. It's a change into our ecosystem, and this is something to be taken into account if your industry or your company wants to migrate to this tool. And finally, so it's a choice. You can deploy Prometheus in different ways. In order to rely on existing tooling and in order to rely also on all the service discovery provided into Kubernetes, we decided to deploy our Prometheus in a Kubernetes ecosystem. So now, let's talk about the architecture, if it wants. I'm sorry. Voilà. It opens.
I think it's.
So our ecosystem.
As a WebEx meeting, is just over.
Okay. So
let's move like this.
So, as you will see into the next slide, basically we decided to deploy the Prometheus ecosystem in an HA way, as it was displayed in the previous slide. So we scribed twice the same endpoints with 2 Prometheus servers. We duplicate the alert manager to make sure that the alert is always triggered when it needs. And what we see as well is everything is deployed into Kubernetes. For a user perspective, the user does not want to manage 2, 3, or 5 Prometheus servers if you deploy your server into an HA way. So what we decided to do is to provide a single API to the user, which will be actually the So I explained already this. So we have an HA deployment of the Prometheus stack. We deploy all this into a Kubernetes ecosystem. And as mentioned, we want to make the life easy for the user. So instead of asking the user to configure each Prometheus, to configure each alert manager, we just ask the user to provide the configuration into the config map of Kubernetes. Yeah. It does not work. Voila. So we just ask the user to push this configuration into Kubernetes. On the other hand, it's a tool that has already been presented before. We have the Prometheus operator that is there to make sure that the configuration pushed by the user is properly propagated to the Prometheus servers, to the alert manager, and the user do it only once. So sorry for this. The Prometheus operator watches the configuration and propagates it to the Prometheus and alert manager. What we see as well into Amadeus is that we are not directly using Slack or the emails or the SMS. We have an internal escalation system, and to be able to plug our ecosystem to the alert manager, we created this simple alert translator. Finally, what are the feedbacks? So first of all, I will not talk a lot about this. It's a great tool. People have good feedback on it. We saw right before that people are going even faster than us to integrate Prometheus. The query language is great. The solution provides an easy way to increase the monitoring coverage of Amadeus. Basically, application integrates natively the Prometheus API. People are able to create their own metrics on their own to add it to the monitoring system. They can define their alert. It's a great solution. However, in our scope, into our team, what we see as challenges is, first of all, as I said, the migration is not effortless. we have some change management to do. People are used to their applications, the ones they use on their day-to-day work, and we need actually to build with them to migrate to Prometheus and to help them to migrate. Another challenge is that in Amadeus, we don't want to use Prometheus only into a Kubernetes ecosystem, but also for all our legacy applications. And we see a challenge with anything related to the service discovery. We need to provide a solution that is flexible enough for an application to subscribe to this service discovery and for Prometheus to collect the relevant information. And finally, as I said, Prometheus is not the magic solution to cover all the monitoring use cases. However, for anything related to the metrics-based monitoring, I think it's the great tool. Voilà, that's it for me.
So thank you. It's time for a question, if you have any, to any of our speakers. It was that clear that there's no question? Okay, so yeah, one here. It's done by Cube. There is the horizontal pod autoscaler that is today plugged. I think it's on Hipster, but they plan to move to Prometheus-based metrics.
You can already do it if you want. You can use, for example, the number of requests that you receive on a Prometheus metric and do it and use it to scale your deployment with that. You need to define some stuff and to have a service doing it, a controller doing it, but it's possible to do it.
If you want to do it yourself. But basically, look at horizontal pod autoscaler in the documentation of Cube, and you will see that they plan to use the Prometheus as a source of metric.
What about checking the health of pod when we're rolling out a new deployment?
So
basically carry testing, carry deployment.
yeah, testing if a pod is healthy or not, there are many ways. Of course, there's the probe. You must have heard about probes. We probably have a talk about that. You can use Prometheus to do few things around this, especially if you want to expose some functional metrics that are only seen by the export that you are doing. If you're interested, we have some prototypes that are running where we scrap some functional metric and try to find out if any pod of a given type is behaving a different way than the other ones. And we are able to put it out of traffic, pause it, or something, a few things like that. So you can use Prometheus and the metric that you export to detect if something's wrong. But if you need to check some, let's say, technical stuff like response time, error code, HTTP code, and so on, you probably don't need Prometheus. You have other layers inside Kubernetes, inside service mesh like Istio that will help you. The why was said by Johan, I think, from this guy. I haven't chosen anything. I'm just trying to give you some insight on this technology. There are other solutions for monitoring, and if you look at, for example, Sysdig, Datadog, there are many things. They are mostly SaaS solutions, so you will have to kind of offload your monitoring to another system out of your cluster. So maybe you can be happy with this kind of solution if you have small system, but especially in Amadeus, I don't think that we want to export all our metric to another system that is running outside. This would be one reason for not using them, at least. Is there any other?
One other reason to use Prometheus instead of others is the scalability possibility of Prometheus. when you compare the possibility and the number of metrics that he is able to scrap, he's done the job greater than the other solution. I don't have names, but you can go to the Prometheus.io and you have a section that it compare the result. Of course, it's on this website, so maybe it's not always very. It's maybe for Prometheus, but on internet you can see a lot of people is happy with the performance on Prometheus. And another point is that Prometheus is quite new, and he was created to run for a cloud application. So for that, he don't have all the legacy stuff, and he's very focusing of these new use cases, and that's why people are happy to use Prometheus for that.
Yeah, as said by Cedric, there's the performance aspect, but also on the operability side, it's really simple. It was said by François, it's something really stable, and that you can really adapt to your operational use case. If you want a tree of federation, you can do one. If you don't want, you don't do. It's easy to configure, especially it's easy to deploy. Now within Kubernetes with CoreOS operator, there are many, let's say, pros for using this solution, especially if you go in a CNCF context. Not that I know. On the Grafana side, you have been distributed an URL, but it's Grafana, it's not Prometheus. You can deal with users who have access to who can build dashboard, who can read, and so on. On the Prometheus itself, there is no user management at all. So if you run it in your cluster, you run it with a particular privilege, okay, a service account in Kube, and it's scrapping data, and whoever has the same service account can interact with the pod, for example. But it's kind of closed loop, you know. There's no way inside the UI of Prometheus to configure it through the UI. If you don't have the hand on your own Prometheus pod, you won't be able to inject anything there.
You can do.
Just to restrict the access of the dashboards of Grafana and Prometheus, we just use ingress credential inside Kubernetes in order to have a basic HTTP authentication. Just because, of course, we maybe don't want anybody that has access to our company network to be able to access to some metrics, some critical metrics, but yet is not provided at all by Prometheus. We just use other services like Ingress or anything else that you can use to access your service. So you if you have an endpoint, you can have a firewall behind it, you can have anything you want, but it's not provided by Prometheus at all.
Other questions? No? Yeah, Leo? Exact. So to do that, you can scrap anything, even if your Prometheus is inside Kube and you have machines running on your legacy system. The only important thing is that within the configuration that you give to Prometheus, the IP addresses that you give are visible from that cluster. So it's just a matter of network setup. So for Amadeus people, you know that our orchestration mechanism is called the master agent. We have created a controller that extracts valuable data from the master agent and that feed a Prometheus configuration. So we have a Prometheus that is running inside Kube that is able to scrap node exporter that are running on legacy nodes. I didn't do the POC with e-commerce. I did it only for the OB part. Yeah, as I said during the presentation, if none of the service discovery mechanisms that are proposed by Prometheus fits your need, you still have this SD file and static SD that is really nice because it's just file-based. So each time you change the file, you have Prometheus re-looking at the configuration. So if you manage to build a controller that extracts your IP's address from your system, You build these files, and boom. Other questions? So, as said in introduction by Luc and Boris, we have this meetup website. We are happy to get some feedback from this presentation, but also any other topic related to SNCF or distributed system that you would like us to discuss, and we'll be more than happy to have contributor also to this meetup. Okay, thank you very much for attending and for being there so late.
So if you want to play with what we showed during the demo, you have the first links. I think it's on the paper also.
Yeah.
That we distributed.
You have all the link on the paper, and the links will be also on the meetup site. So if you want to run the demo, of course you will need some project and so.